well, right?
Yes,
okay.
It's okay, yeah.
Good. Well, thank you for inviting me. And let me also acknowledge my co-authors, Jason Morgan, Alina Polonia, and Giancarlo Molli. As you can see from the title, we are going to talk about serpentinite peridotites in different moments of the Wilson cycle. So in this talk, we propose that sub-continental serpentinite peridotites get exhumed during rifting and keep being re-exhumed to the top of the surface from the overriding plate, and then gets sort of embedded into collisional orogens. So, and therefore this idea of the Wilson cycle. The motivation comes from a paper that was published recently by Alina Polonia, and she described the presence of some serpentinite peridotite diapirs in the Calabrian arc. So here you can see an image. I won't really go into details of how she came to the conclusion that they are serpentinite peridotite diapirs, and here you can find the references, but I want to point out a couple of things. The first one is that, as you can see, they are grouped in the inner part of the Calabrian forearc, in a region where we don't really have in the incoming plate sediments, salt that is related to the Messinian salinity crisis. So these diapirs are not really related to salt tectonics. The other thing that you can see here in these seismic reflection profiles is that they are cutting through the décollement of the Calabrian forearc, and they possibly come from quite deep into the incoming plate. The interesting thing about the Calabrian arc is that here we have the ongoing subduction of the Tethyan ocean continent transition. You can see here it's sketched, and the idea is that these serpentinite peridotites are reactivated sublithospheric serpentinite peridotites from the Tethys passive margin. I should also mention that the independent work done through geophysical work have indeed described the incoming plate as being characterized by serpentinization. The idea then of these diapirs is quite different from the other diapirs and the serpentinite mud volcanoes that have been extensively described, for example, in the Mariana Trench, where their feeding system is supposed to be from the overriding mantle wedge. In this area, instead, the idea is that this diapirism is occurring from the incoming plate. And therefore, the question is if these serpentinite peridotites were already exhumed near the seafloor during the Tethyan rifting. And here I bring you into the Northern Apennines. So you can see here from the inset where we are basically in Liguria. This is the northern part of the Northern Apennines. And in particular, I'm going to show you in this picture some blocks of ophiolitic material that is coming from these light green units. So these are what is called the external Ligurian units. So they were sediments that were deposited in the Apennine Tethys. And here you can see that the serpentinite basalts and even granitoids blocks are cropping out within some embedding sediments of Campanian age. And the data that have been collected, particularly over the last 20 years, are telling us that these blocks are coming from quite a broad, over 150 kilometers long continent-ocean transition domain, where we had indeed exhumation of seafloor to the seafloor of these serpentinized peridotites. In other words, this would be a situation quite similar, for example, to what we see into the Iberian margin. And again, I won't enter into details because here there are experts on the Iberian margin, and we have seen the presence of serpentinization occurring near or at the surface. The other interesting thing about this diapurism in the Calabrian Arc is that it looks like it is facilitated by the presence of these strike slip or transtensional faults that deform the subduction system. And as you can see here, they are quite perpendicular to the front of the arc. These faults are interpreted as being the reflection on the overriding plate of structures that are characterizing the incoming plate. In other words, these would be step faults, which are subduction tear edge propagation faults that are in other words, faults that are tearing the slab and that are also deforming the overriding plate. So the presence of these lineaments would provide, in other words, rooms for these diapirs to go through the subduction system. Now, these faults, these transform faults, fractured zones are inherited from the Tethyan, the Apennine tethys. And here you can see one of the many reconstruction of this branch of tethys. They are, I would say they all have in common that the Ligurian tethys seems to be cut by quite a bit of these transform faults and fractured zones. And in the 70s and the 80s, work that has been done in the Northern Apennines, looking at these blocks of ophiolites, had indeed interpreted these blocks as coming from oceanic diapirs that were intruded into the transform faults and the fractured zones. So these ideas are actually not new, and they are really coming from the setting of these blocks in the field. I should also mention that these fractured zones also played a big role during the beginning of subduction. Here we are in the late Cretaceous, and this is one of the cartoon that you can find that is showing these the early phases of subduction. And the interesting thing is that these fractured zones are transferred as lineaments into the continental crust. So they are present as a continuation of these fractured zones into the continental crust. And indeed, lineaments that we find in oriented in a transversal way are found in the Northern Apennines. Here we are in a section of the mountain belt that is southern of the area that I was showing before. And again, since the 70s, people have described these lineaments that are sort of controlling outcrops and deformation features within the southern part of the mountain belt. And recently, they have been related to tears in the to tears of the incoming slab of the slab. So again, we see a more advanced snapshot of what we have described for the Calabrian arc. In this part of the Northern Apennines, and let me put it a little bit bigger, this is just to show you that, again, these things have been described already in the literature, so a little bit bigger, but you can see that these stars are representing the outcrops of these serpentinite-rich blocks of ophiolites within these oceanic sediments. And you can see that they do align with these lineaments that are interpreted as being the upper plate structures reflecting these tears in the slab. You can see here.
Paola, you have 10 minutes.
Okay. Here you can see one of these blocks. This is actually coming from this outcrop here in southern Tuscany. And these sediments, these blocks, have been described in the past literature as due to mass wasting, to debris flows. Here, though, we want to push the idea that they might actually be the further evolution of these serpentinite peridotites diapirs that were intruded into the subduction system. So in other words, we go in a situation like this, where we have these diapirs that are intruding into the subduction system, and as the deformation keeps on developing, they are decapitated and shorn, and then they get embedded into the orogenic wedge. So we have seen that during rifting and continental breakup, these serpentinite peridotites can get close to the surface or to the surface, and that in the Northern Apennines, for example, this situation has been described for the Apennine tethys with a wide passive margin with these characteristics. These serpentinite peridotites then can they be reactivated and intruding into the subduction system, and later on they can be shorn and incubated into the orogenic wedge. Now, if this hypothesis is valid, then this would explain, for example, why in most accretionary prisms, the blocks of ophiolite that we found are represented by serpentinite and subordinate basalt, and very rarely they are comprising gabbro and sheeted dikes. And also this would explain the wide range of ages and origin of these ophiolitic blocks. It also opens interesting scenarios for subduction processes, because the plate interface, the subduction channel, the shear zone, would be prone to be sort of pierced by these diapirs, introducing, for example, exotic fluids and a lot of heterogeneity within the shear zone itself. And so would bring to a concept of a sort of a leaky subduction channel. So with this, I finish, and thank you for your attention.
Okay, your time has come. It's a very interesting subject. It's actually very interesting. This link to subduction zones. I see that Marta did not see something. Marta, can you unmute?
No, it was an answer to Susanna, but
okay. Then,
I don't have a question anyway.
Okay. Yeah, I would have a question, because I was wondering how much stabilization occurs on the margin or during the exhumation, and how much in the subduction zone, and if there are ways to tell them apart by geochemistry, by types of fluids.
Yeah, well, I can tell you that in terms of serpentinization, for example, the serpentinization, the amount of serpentinization that has been inferred for the mantle of the incoming plate in the Calabrian arc is about, say, 70 to 75%. In the field, I mean, you know these rocks as much as I do. I mean, it's very difficult to find anything that has any resemblance of being fresh. In terms of geochemistry, this is actually a key question, and this would be the interesting part to sort of the further work on this subject, because possibly during sort of piercing of the subduction channel, probably there will be some fluids and some deformation phase that are also exotic to these serpentinite peridotite blocks. So that would be obviously the next thing to do.
Okay, I saw that, I see that Matilda has a question. Can you ask? But you should not answer too long because we are approaching the 5 o'clock.
Okay, so yeah, Paola, I had a comment to say that the rarity of gabbros and sheeted dikes is actually typical of melt poor oceanic slow spread oceanic lithosphere, so that it's not necessarily an indication. And then I was wondering what evidence in the sense that you just talked about, like deformation, fluids, etc. Do you have that these are indeed dipiers? Because it's very convincing, the presence of dipiers in the seismic lines from the Calabrian arc, but these have not been sampled. So
exactly, yes. Right, no, I mean, this is something that Alina is working actively, and in fact, there will be also a Magellan Plus workshop organized and funded by ECORD. The idea would be to go and to try to sample some of the fluids, at least, that are percolating on top of these dipiers. Obviously, it has been postponed due to the situation. Possibly there will be some work done in the next few months, because Alina found a window of sampling with an Italian research vessel. So, I mean, let's see. Obviously, this is an hypothesis, and it's sort of reconciling also some of the ideas that were coming up from looking at these blocks in the field, because particularly those in the southern Apennines, in the southern part of the northern Apennines, has always been a problem to interpret.
Okay.
Yeah,